Have you ever experienced difficulties in placing components when building prototypes? Proper placement of sensors and actuators is crucial when designing spatial and proxemic interactions. However, many challenges arise when you attempt to position these components accurately, often resulting in building and testing prototypes without precise spatial configuration. To address the issue, we propose the concept of spatial physical computing, which integrates extended reality, digital fabrication, and visual programming to bring spatiality into physical computing. As a demonstration of this concept, we introduce SpatIO, an XR-based physical computing toolkit that supports a continuous end-to-end workflow. The workflow of SpatIO is structured into 3 phases: the virtual phase, the mixed phase, and the real phase, which together form a continuous pathway from virtual prototyping to physical implementation. In the virtual phase, the first thing you'll do is shape your product by setting the size. Then, you can select and add sensors and actuators from the component list. Moving and rotating these components is simple and intuitive, just like handling physical objects. The grid snapping feature ensures that placement will be consistent when transitioning to physical components later. Once you've placed the components, SpatIO simulates their operation using body tracking data from the headset. It also visualizes the input and output values, both numerically and graphically. You can also write a flow-based program for the product directly within the virtual environment. A node is automatically created for each component, and you can add additional nodes from the palette, like arithmetic operations, Boolean operations, conditionals, and more. The nodes can be moved anywhere in the 3-dimensional space and connected to other nodes. The real-time value visualization in each node makes it easy to debug and refine your program. Now, we move into the mixed phase. In this phase, you can substitute virtual components with physical ones using SpatIO modules and a pegboard. By picking and combining an IO module, positioner module, and attachment module, you can easily place a physical component exactly where its virtual counterpart is. Then, simply plug a socket from the component into the hub module to connect it to the system. At this point, SpatIO will automatically switch from the virtual version to the physical version of the component. The system works seamlessly with this mixed configuration of physical and virtual components, automatically detecting whether each component is physically placed or still virtual. You can test the prototype with mixed or real components, adjust the code, and modify the placements as needed. With the help of AR markers, SpatIO keeps track of any movement of physical components, updating the augmented visualizations accordingly. Finally, we enter the real phase. Once all the virtual components have been replaced with physical ones, your prototype can now work fully independently of the VR headset. You can now remove the headset and interact with your complete physical prototype. At this stage, the prototype can be tested, used, and further refined as needed. If adjustments are required, you can always return to the earlier phases to make changes. In summary, SpatIO offers a seamless workflow that bridges virtual and physical prototyping, allowing for efficient design, testing, and iteration. By integrating XR, digital fabrication, and flow-based programming, SpatIO makes spatial physical computing more accessible and powerful. Thank you for watching.